Okay, so these screencasts have a 5-minute maximum. That's the technology I'm using, and I was not paying attention either time because this proof ends up being really long. So sorry about the abrupt ending again. So what happens, right? So I'm trying to figure out what happens when I subtract these. I picked my m's such that everything here is going to cancel out. So I'm going to be left with a whole bunch of b's, which are really a's since these are just rearrangements, where now all these a's are bigger than n. All these subscripts are bigger than or equal to n, which means that I'm going to get something less than any of these partial sums of absolute values. So, right, I get a bunch of a's. I can use the triangle inequality to put absolute values to add all these up together separately. But this looks like it's part of a partial sum of absolute values. So this is less than or equal to, right, this is less than or equal to, if you include all the terms. I'll show you the analogy over here in just a second. And this, by n sub 2, by definition of n and n sub 2, that's less than epsilon over 2, which is exactly what we want. So the n log over here, I have that what I have over here is, right, T7 minus S4 gave me A6 plus A9 plus A5, which is less than or equal to A6, absolute value, plus absolute value of A9 plus absolute value of A5. Going from here to here, the analogy of what's going on here is that this is A5, A6, A9 is missing some terms. So this is analogous to saying that over here, that this is less than or equal to A5 plus A6 plus A7 plus A8 plus A9. Certainly if we add more non-negative terms, it's going to make it bigger. The advantage here is that this is part of a Cauchy criterion statement for the series with the absolute values. So I can use the Cauchy criterion here to say that this is small, this is smaller than that, and this is even smaller than that. So you keep on getting smaller. And so T7 minus S4 is ultimately smaller than this thing, which is small by the Cauchy criterion. So this thing is less than or equal to a bunch of these a's, which is basically smaller than something that I can use a Cauchy criterion on, which is epsilon over 2, which allows me to finally put it all together for m bigger than or equal to m, where m is the max of the f sub k's. Basically, I want to go up far enough in the rearrangement so that I'm going to avoid all of the terms that come before n, where n is defined like so. Once I do that, I get Tm minus a, split it up, throw in these two s sub n's, and then split it up. This thing is less than epsilon over 2 by essentially the Cauchy criterion with a whole bunch of kind of clever inequalities in between. This is the complicated part. Plus this thing, oh, but that's just straightforward. That's just the fact that the original series converges. So this one was really easy. That's less than epsilon over 2. This blue and red one, that was a hard work. But it does it. So it shows that the partial sums for the rearrangement minus a is less than epsilon for whatever we like. Now we're finally done with this.